Hi, my name is Aishi Jang, and today I'll be going through some worked problems regarding the concept video on polar covalent bonds in water molecules. Question 1. Within a single water molecule, the oxygen atom is bonded to the two hydrogen atoms by A. Hydrogen bonds, B. Non-polar covalent bonds, C. Polar covalent bonds, D. Ionic bonds, and E. Van der Waals interactions. Take a moment to think about this question. If you answered C, polar covalent bonds, you are correct. Now, in the question, we're essentially asking for an intramolecular bond. We're talking about the bond between the oxygen atom and the hydrogen atom. So we're looking for a bond within the molecule itself. Immediately, we can eliminate the answers that correspond to intermolecular bonding, like hydrogen bonds and van der Waals interactions. Now, the difference between non-polar covalent bonds, polar covalent bonds, and ionic bonds have to do with the electronegativity difference between oxygen and hydrogen. Now, this difference in electronegativity is not great enough to be an ionic bond, but it's too great in order to be a non-polar covalent bond. And since the oxygen is electronegative enough so that the electrons spend the majority of the time closer to the oxygen, but is not electronegative enough to completely steal the electrons away, it is a polar covalent bond. Question number 2. The attraction between the slight negative charge at one end of a water molecule to the slight positive charge of another water molecule is called A. Hydrogen bonding, B. Covalent bonding, C. Van der Waals forces, or D. Ionic bonding. Take a moment to think about this question. If you answered A, hydrogen bonding, then you are correct. In this question, we're asking for an intermolecular bond, or bond between two molecules. So immediately we can eliminate the choices B and D, because these are intramolecular bonds. And van der Waals forces are caused by electrostatic attraction between temporary dipoles and induced dipoles that are caused by movement of electrons in atoms and molecules. So this is incorrect because, as we know, in the water molecule, there is a permanent dipole. The oxygen end has a partially negative charge, and the hydrogen end has a partially positive charge. And the hydrogen can form a hydrogen bond with the oxygen from another water molecule. So the answer is A.